what we've done here is taken just a sort of a pencil beam snapshot through the universe by putting together 10 years worth of images from Hubble. It's really the deepest image now that's ever been taken. And so when you look at the image, you see these fuzzy little objects in different colors scattered across it. These are all galaxies. You know, our Milky Way galaxy is sort of an ancient galaxy that's been built up over the last 13 billion years of the life of the universe. But when we look at an image like this, we're looking back in distance, and we're going so far that the light from each of these objects has taken billions of years to reach us. And so we're looking back in time through the universe. And we go back from the brightest ones you see in there, probably 5, 6, 7 billion years ago, to the very faintest objects, which are close to the Big Bang. What it really is showing is how the universe got to be the way it is today. You know, the universe is sort of a big empty region that sporadically has a galaxy like our Milky Way, like Andromeda. These huge galaxies, often with smaller galaxies around them. So the universe is in a sense in its old age now. It's formed a lot of the stars that will ever form. And so one of the key questions, of course, is how it got to be like this. What happened over the 13.7 billion years of its lifetime to make it like it is today? And remarkably, unlike archaeologists, you know, we can actually go back in time and see what the building blocks look like. And so as we go out in distance and back in time, we're seeing galaxies that were the precursors to the great galaxies of today at an earlier stage in their life. So it's like looking back to when folks were teenagers, toddlers even, and seeing what they were like then, but doing it in a time machine way. So it's a wonderful opportunity to actually see things in the process of forming, growing, changing over time. Yeah, I would just say that this is, I think a stunning demonstration of the power of the Hubble Space Telescope and of the power of telescopes to explore our universe and to understand the origins of galaxies and stars and how our own Milky Way actually built up. And so this relates, I think, to one of the great questions that we all have about origins. We're always asking about the origins of people, of life on Earth, Earth itself, the solar system, of stars and the Milky Way. And here we are exploring directly one of those great questions, because the very solar system that we live in now came about 5 billion years ago as part of the growth of the Milky Way, and we're exploring even earlier times than that, before our sun was even born, and seeing what galaxies looked like and how they came to be.